So welcome all students. Today actually we are trying to learn something about non-recursive descent parser. In the last video we have seen something about recursive descent parsers, where we have understood that these parsers will have in recursive descent parsers, for all the non-terminals you will have to create procedures, and these will be called whenever such strings or such symbols are encountered. Accordingly, you also saw that there can be some kind of backtracking, if at all backtracking is allowed. In that case, what will happen, you will choose one of the production, go in a particular depth, and then realize that okay, whether it is correct production or not, and then you can backtrack and choose another production. However, we also learned that there can be some kind of prediction. You can predict that these kind of production is helpful. I mean, this will be better to choose. In that case, you can choose a particular production. For that, different kind of I should say a tabular structure can be made, that in this case this particular production is helpful, right? This tabular structure is also helpful in this non-recursive descent parser. So today we will see how this table is created, and we will also see how LL1 parsing algorithm works, right? So basically here you have to see that LL1 parser is this, right? Okay, if at all you have LL1 parser, in that case you have three more things. One is input, right? And this input is ended with a end symbol. Okay, usually we can take it as a dollar, right? So after that you have we call it parsing table. Okay, so this LL1 parser will use this parsing table as well as use the input, and then it will also use a stack, right? This will start with the dollar symbol. So it can always put something in the stack and pop something from the stack. So in this way, this parser will use these three things. So first is input. You already understand that input will be a string followed by a dollar symbol to show that the string has ended, right? And then there is something called parsing table. So we will see today how this parsing table is created, and this is a stack which will be repeatedly used to put some production or a terminal or a variable in this stack and remove those whenever required. So we will see how parsing happens. For now we have to understand the parsing table creation, right? How this parsing table is constructed. So let us start with parsing table construction. So I am telling you today something about LL1 parsing table construction algorithm, right? Parsing table construction. So while writing I have to be fast. At the same time we have to also consider that the handwriting will be not too bad. So LL1 parsing table construction. So what actually you have to do here, let us assume we have a grammar, right? Let me name this grammar as G. Okay, so according to the book, if you write, you will say that we have an input. What this input is? The grammar G. Okay, now what you want in output? In output you want a parsing table, let us name it as M. Okay, so what you will do here in this parsing table construction, okay, what the method is? Just two steps, I should say, the two steps which are repeated. What you have to do here is, for each production, something A derives alpha. What you are going to do? You will repeat these things. Number 1, for each terminal alpha, in the first of alpha, you will add this production A determines alpha to M. Okay, let me say it like that. You will add this production A derives alpha, where you will add this under M A comma A. Okay, let me write it like this. Okay, what is this A? Where A is first of alpha. Okay, so you will add this production A derives alpha in row A, column this A, where A is the first of alpha. Now the second rule, second thing that you have to do is, now this first of alpha, if it contains something like epsilon, then you will have to keep this in the follow of A also. Okay, so if this first of alpha contains contains epsilon, in that case what you will do, then you will keep this production, in M A comma B, right? What is this B? B is the follow of, B is element of follow of A. Okay, where B is element of follow of A. So these two important things that you have to do is, given a production, you will try to find what is the first of the right hand side, and you will insert this production in the first of this right hand side. And also, if this first contains epsilon, in that case you will have to keep it in the follow of A also. Okay, so let us take an example. Now this example may be, if you remember, okay, you know that now we are talking about grammar which is free from left recursion, right? Let us take an example which is having left recursion. We will remove the left recursion and then we will use for making the construction of the table, right? Let us assume the grammar is like this, right? E derives E plus T and T also, and T derives say T star F and F also, and F derives, suppose like this, or it can be ID. Okay, ID is okay, ID can be 1 2 3 4 5. So how will you convert it to non-recursive? Right, it will be something like suppose E will give you, you will keep this T and a new variable E dash, right? And this E dash will be this part plus T E dash. Along with this it will have epsilon, right? Then considering T, what will happen to T? T will have F and T dash, and then you will have T dash which will give you this part, star F as well as T dash itself. Along with that it will have epsilon, right? F has no left recursion, so it is okay. F will give you E as well as ID, no problem. So for this grammar now we are going to create a say table, right? So in this table what you will have is, suppose basically in this column, first column, I should say, you will write something about the non-terminals, है ना? So what are the non-terminals? These are the non-terminals: E, E dash, T, T dash, F. So E, E dash, T, T dash and F. These are the non-terminals. Along with that, what are the other things, means symbols? One is ID. Okay, other than ID you have parenthesis, two types of parenthesis, a star symbol along with that plus symbol, right? Nothing else. So let me write it. One is what happens if ID comes. Okay, then what happens if plus symbol comes, then what happens if star symbol comes, then what happens if opening parenthesis comes, and what happens if closing parenthesis comes. And that is not the all. One more entry will be for dollar. What happens if the ending symbol comes. Okay, so now you have so many productions. One is this, second is this is also a production, third, 4, 5, 6, 7, 8. So you will have to insert these productions here, right? You remember the rule. Let us consider the first production. It is E gives something. So for this you will have to find out the first of this part. First of this part means first of T. First of T will give you first of F. First of F will be either this thing, opening parenthesis, or it can be ID. So this will be inserted in two places, right? Here as well as here. So let me insert it. It will be E derives T E dash. Okay, you can write the whole production, or you can write just the number. You can number these productions and you can write the number as well. Okay, let me write the whole production. It is E derives T E dash, no problem. Similarly, the next production is this thing, plus T E dash. If at all it is something plus, that means the first of this part, first of this part, right hand side, will be plus symbol only. So this will be inserted here only, right? So E dash derives plus T E dash, no issues. One more production is there, E dash derives epsilon. So where it should be kept? We remember one rule, that if at all it is epsilon, in that case it will be kept in the follow of E dash. What is the follow of E dash? Follow of E dash will be, let me find out. Follow of E dash will be follow of E dash. Follow of E dash will be follow of E. Okay, and follow of E will be two things. One is a start symbol, and another is, if at all it is coming somewhere, it is coming here, so follow is this thing also. So closing parenthesis as well as dollar. So it will be kept in two places, which are closing parenthesis and dollar. So let me keep it here. It is E derives epsilon as well as E derives epsilon, no problem. Now for T, T derives F T dash. Okay, so first of F T dash is first of F. First of F is this thing, opening parenthesis as well as ID. So it will be kept here only, an ID. It is T derives F T dash as well as opening parenthesis, T derives F T dash, no issues. Now the next thing, it is T dash. T dash is here. This T dash, the first of this part is start symbol, so it will be kept here in start symbol. Is there anything in the first of it? No, nothing. So it will be kept here only. It is T dash derives star F T dash. Okay, anything else? The next thing can be t dash derives epsilon. So t dash derives epsilon means it will be inserted in follow of t dash. Follow of t dash will be follow of t dash, and here also follow of t. Follow of t is first of e dash. Okay, first of e dash, and nothing else, right? So first of e dash is plus symbol, है first of e dash is plus symbol as well as epsilon. So plus symbol, so it will be inserted here, t dash epsilon. Now if in the first of e dash we also have epsilon, in that case it will be inserted in follow of e dash. Follow of e dash is the follow of e. Follow of e is dollar as well as closing braces. So closing braces, here it is t dash derives epsilon, and here t dash derives epsilon. Now the next thing is f. The first of f is id and this part, so here first of this, f derives this part, so first of this part is this only, so it is here f derives this thing, right? Nothing else. Next production is f derives id, so first of id is id itself, so f derives id. In this way you can create a table. The name of the table is m, right? Now later on you will use this table for parsing some given string. Okay, so what will happen? For parsing, we will come to see this example again. Let me write the algorithm first for parsing, right? So you can call it as LL1 parsing algorithm. Okay, so here let us consider two important things. As you remember from the diagram, that you will have a parsing table, right? You will also have input, you will have a stack. So you will have to understand that there always be a symbol to be read from the input stream, and there will be something in the top of stack. So let us assume A is the first symbol of string W. Okay, let A be the first symbol of W. Okay, then what will happen? Suppose X is the on the top of the stack, X be the top stack symbol. Then what you have to do is you will enter a while loop. While loop will be for a condition. Okay, until that particular condition is true, you will have to check a few things and do accordingly, right? Till now you understand that M is our table, M is the name of our table, and these are certain terminals and these are non-terminals, as well as this can be entry, right? This entry is on the place M E dash comma plus, isn't it? So now let us see the algorithm. So till the time a stack is not empty, you will have to repeat something, right? Suppose okay, if this x is equal to a and it is dollar as well, then you can say that it is success, right? Then you will come out. Otherwise, in certain cases you can come out with error, and in other cases you will put something, okay, in stack you will pop something from the stack. Okay, so let me say this algorithm in simple words, where the first thing is you will check if this x is equal to a and it is also equal to dollar. If at all this condition is there, in that case it is successful, parsing is successful. Now the second thing, let me say this is the first thing you are checking. Second thing you will check, while writing you can write if else if kind of thing. So second thing you are checking is if x is equal to a and it is not equal to dollar. Okay, this x is straight. So in that case what you are going to do? Nothing you have to do. You have just to understand that something that you have in the stack, top of the stack, is same as what you are getting in the input string. In that case you will pop the stack and increment the input pointer. Increment the input pointer. Then if x is a suppose variable, variable means non-terminal. In the top of a stack, if you have a non-terminal, in that case what you are going to do? Let me write it. If x is non-terminal, then what will happen? You will have to see the entry in mxa. See the entry in the table M. Which entry? X comma a. Okay, a is the input string symbol and x is the top of the stack, variable in the top of the stack. So you will see this entry. Now if this entry means, definitely this entry will be something some production, right? So here you have to see what you are going to do with this production. Assume if this entry mxa is some production is like x derives something ubw, then what you are going to do is replace this x in the stack, replace this x with opposite of this in the reverse order, wbu. Very simple. That is what you are going to do, nothing else. Now in other case there can be error if at all you have found something, a symbol in the okay, here only see the entry, and you can consider it as 3.1 and there will be 3.2. So if this entry mxa is blank, blank means in the top of a stack you have a non-terminal and in a string you have a terminal. So with this combination there is no production which supports this combination, right? There is no production that can derive this particular symbol in the input string, right? In that case you can say there is an error. Very simple. So this is a simple, I should say, algorithm for LL1 parsing. So basically you will have this table. In this table these are the non-terminals and these are terminals. You have something in your stack, right? And accordingly you have these things. Accordingly you will see whether what is the production and this particular ID, whether it is matching, we are getting something or not, and accordingly you will see in last if you are getting if you are getting this thing dollar at all the places in the stack, your stack is empty, this particular input string is going to be dollar, means you have reached the end of a string. In that case you can say that you have successfully parsed this string. The syntax of this particular string was correct according to the current grammar. Okay, so this is something we are doing.